Hi guys, welcome to my channel. In this video we are going to solve a questions about the structural analysis. The question will be analyzed due to a moment distribution method, and we have a beam now you can see on the screen with 4 supports, and it ends with pin. It ends with pin and also roller. So we are going to use the modified formula when we determine the stiffness factors. Okay. So now let's write the fixed end moment. Then we are going to try to find the stiffness factors. But before we solve the question, if you like these videos, if you want to see more of the videos, please subscribe and share with your friends. If I did anything wrong, please comment. I'm going to check all the comments, and I'm trying to make the channel and the questions for you better. So let's solve the question. Now, fixed end moment from B to A, because we won't use from A to B, we are going to use a modified formula. Okay, so from B to A, look at here, we are going to take as this one as fixed, and this is also simply support, and so it's going to be, we are going to use this one. Okay, so sorry, we are going to use this one, 3 PL over 16, because this is the point load. 3 multiplied P, 10, multiplied 8 over 16 equal to 15. Okay, and now let's calculate from B to C. What is fixed end moment from B to C? It is, we are going to use this formula, because look at here, this will be as a fixed and this will be as a fixed, and so it's going to be calculated from this formulation. From B to C is going to be W. What is W? 5 multiplied 8 as L square over 12. And this is going to be equal to minus 26.667. Yes. And fixed end moment, CB, is going to be the positive of that. And this is kilonewton. Sorry. We have to always specify the units. And we are going to determine the fixed end moment for this part also. It's going to be from C to T. C to D, yes, C to D. And this is going to WL square over 8. W is 5. Multiplied L square over 8. And we are going to obtain as 40, right? 40, but it's going to be negative. Yeah. So now let's write the fixed end moment in its own place. And for example, this is going to be 40, and this is going to be 0, because this ends with roller support. And this is 26.667 minus 26.667, and this is 15, and this is 0. And so let's determine the stiffness factors. Stiffness factors for BA. We are going to use the modified formula. So 3 multiplied 2EI, okay, over 8. So this is 0.75. So stiffness factors for BC is 4, because it's going to be used the normal formula. 3EI over 8, and this is going to be equal to 1.5. And stiffness factor for CD, for this one, is going to be used the modified formula again. Multiply 3EI over 8 is equal to 1.125. So distribution factor for BA, it is equal to 0.75 over 0.75 plus 1.5. And this is going to be equal to 0.333. And for distribution factor BC, 1 minus 0.333, 0.667. So now let's find for CB. It is going to be something like that, 1.5 over 1.5 plus 1.125, and it's going to be 0.571, and distribution factor for CD, it is equal to 1 minus 0.571 equal to 0.429. Okay, now we obtained all distribution factors. Let's write its own place on the table. And for example, for BA, 0.333, 0.667, and this is 0.571, and this is 0.429, and this is 1, and this is 1, because this is simply supported, and the distribution factors for the both ends are 1. Okay, so and now let's distribute the moment. Now we have all the fixed end moments and distribution factors. Let's distribute it. We are going to take the summation of both moment. I'm going to show you just once here, okay? 15 minus 26.667 multiplied it is own distribution factor. Sorry, we forgot to take, we forgot also take the moment here. Sorry, we have a point moment here, okay? Point moment. And we are going to add here as minus 50. Okay, it's going to be minus 50. Because it is at the support. When it adds support, the clockwise direction is negative. So we are going to take the summation of these three for a moment. This one, and this one, and also this one. Okay, these three moments. So I'm gonna, sorry, I made a mistake. I'm gonna take the summation of them here. Also with 50. So it's going to be something like that. 15 minus 26.667 and minus 50. Okay. And multiplied with its own distribution factor, and also multiply minus 1, it's going to be equal to 20.535. Okay. 20.535. And for this one, it's going to be like this. 15 minus 26, 667, and minus 50, and multiplied with 0.667 and multiplied minus 1, sorry, equal to 41.131, okay? 41.131. And this one, we will also take the summation of this both moment, okay, this one, and we are going to multiply it with its own distribution factor and multiply it minus 1, and we are going to write it here as 7.61, okay? And this will be 5.71. And then I cannot make any carryover to this side. I cannot make also any carryover to this side, okay? And we are just going to make a carryovers to between these two moments. So this is going to be 3.81. This will take the half of this here, 20.565. When I distribute this moment with respect to this both distribution factors, and I'm going to obtain minus 1.27 and minus 2.54 and minus 11.742 and minus 8.823, and I'm going to make a carryover, take the half of this to here and half of this to here, and it's going to be minus 5.871 and minus 1.27. And when I distribute this moment into the ratio of this both distribution factor and this is going to be 1.955, and this is going to be 3.916, 0.72, and 0.55. Okay, and I'm going to take a carryover to this both sides, and this is going to be equal to 0.63. Sorry, 36. Sorry. Sometimes I get confused. Yeah, 36. And 1.958. And when I distribute this into the ratio of this both distribution factors, it's going to be minus 1.118 and minus 0.84 and minus 0.12 minus 0.24. Yeah. I recommend you that the last column should be as distribution, okay? If you can, just leave it as distribution, not carryover. It has to be stayed as the distribution. Now I'm going to take the summation of the moments from fixed end moments, okay, from that column, until the last distribution or last carryover. Now this one is the last distribution, so I'm going to take the summation of them. 36.1, 13.899, and 43.39, and minus 43.4. Okay, now we got it. So we got our moments. So let's find the reaction forces and also shear forces, and then we are going to draw shear and the moment diagrams. Okay, so now let's determine it. For example, this is our first part. Okay, this is A and this is B, and we have a two moment here. Let's check what is the moment. We have a 0 moment at A, but we have a 36. Yeah, 36.1 moment here, and we have 10 kilonewton as a force. And also, I guess we don't have anything, yeah, more. We have AY, we have BY, and now I'm going to take the moment respect to A equal to 0, minus 4 multiplied 10. Sorry, this is 4 meter. This is 4 meter. Okay. And minus 36.1. And plus by multiplied 8 equal to 0, and by is 9.51 kilonewton. Okay, now we obtain by, so let's write the total Fy is equal to 0. Total Fy is equal to 0, and it's going to be 10 minus 9.51 minus Ay is equal to 0, and Ay is going to be 0.49 kilonewton upper direction. This is also upper direction. Okay, so let's solve the second part. Now, for example, this is the second part. We have a distributed load. Okay, we have a distributed load as 5 kilonewton multiplied 8 as 40 kilonewton. And now this is we have a Cy, and we have a By. This is By right, this is By left. Okay, so total moment at B is equal to 0. This direction is positive. Sorry, I forgot to write here also. So for this one, I have two forces, and I have also two moments here. For BC here, I have 13.899, and for this one, I have 43. Yeah, sorry, no. I made a mistake. Sorry, I made a mistake. Yeah, let's check the moments. Yes, now for the BC, I have 13.899 and 43.39. So it's going to be at this direction, 43.39, and this is going to be also at this direction, 13.899. So minus 13.899 minus 43.39 and minus 40 multiplied 4, because this is 4 meter. I guess you remember, because the distributed load, when we convert it to point load, it's going to affect at the point load. Okay, sorry, at the midpoint of the beam. Sorry, it's going to be at the midpoint of the beam. And the whole length is 8, so the 4 meter is the half of that. And plus cy multiplied 8 is equal to 0, and cy is equal to 27.16. Okay, 27.16 kilonewton. When I write the total Fy is equal to 0, 40 minus 27.16 minus By right, okay, equal to 0. From this equation, I'm going to obtain as By equal to 12.84. Sorry. Upper direction. Okay. So now let's solve the last part. For the last part, now I'm doing for the last part. Sorry. I guess you understand now I'm not good at drawing here. So this is going to be, for example, this is C right. This is CY right. This is CY left. I forgot to write, but this is DY. So I'm going to take the moment with respect to C, but now first I'm going to write the forces. I have 5 kilonewton as distributed load. Let's check for you. For example, I have a 5 kilonewton. I'm going to multiply with 8. Now you can see 5 kilonewton multiplied 8. It's going to be 40 kilonewton. Okay. And let's check what is the moments that I have. Minus 43.4. So it's going to be for C, for CD, 43.4. And I have here as a force 5 multiplied 8, 40 kilonewton. And this is 4 meter. And this is 4 meter. Okay. So total moment respect to C is equal to 0. And 43.4 minus 40 multiplied 4 plus dy multiplied 8 is equal to 0. And from here, I'm going to obtain as dy equal to 14.57. And the total Fy equal to 0 equation. So I'm going to now obtain the Cy also. And from the total Fy, 40 minus 14.57 plus CYR, right, okay, right, equal to, sorry, it's going to be negative, sorry. Equal to 0. And from this equation, I'm going to obtain CYR as equal to 25.43 kilonewton upper direction. Now I got all shear forces and reaction forces. So let's draw shear and the moment diagrams. Okay, I'm going to draw a shear and the moment diagram to here. So for example, this is my beam for the shear diagram. This is A, this is B, this is C, and this is D. So now this is for shear. I have at A, what is A as my reaction force? 0.49, okay? 0.49. This is really small when you compare with others. So 0.49. And I have a force as 10 kilonewton at the midpoint of beam, okay? Midpoint of beam. When 10 kilonewton is applied, I just show, okay? You shouldn't write something like that on the question. When I apply 10 kilonewton, it's going to, for example, goes down. I'm just trying to show you, just trying to show you, okay? Do not write on the sketch, okay? Do not write this force on the sketch. So I'm going to reach at the point 9.51, and I'm going to continue with the same amount because I don't have any forces here. Okay, now I reach as 9.51. So at 9.51, I am going to check for the B. What is the for the B? By. By. So by is 9.51 and 12.84. Okay, 9.51 is going to apply as it's going to come to 0, and then it's going to be 12.84, right? 12.84. 12.84. Okay, and then I am going to, the distributed load will apply it, and I'm going to decrease as triangular shape. Okay, it's going to be decreased as triangular shape, and it's going to reach the 27.16. So it's going to be 27. For example, this is 27.16, and then I'm going to again check for C. What is the reaction force at the C? One is 25.43, one is 27.16. So it's going to reach as 25. For example, this is 25. Okay. Yeah, for example, 25.43. 1 second. I guess you saw what I wrote here, so I'm gonna draw. I'm going to delete it. 25.43. I've reached that point, and then I'm going to decrease again at the amount of distributed load. Distributed load. 5 multiplied 8 is 40. Okay, I'm going to decrease as at this amount, and I'm going to reach. Yeah, for example, this is my point. Okay, 14.57. Right. 14.57. Now I draw the shear diagram. This is positive, negative, positive, negative, positive, and negative. For example, this length is y, and this length is x. So x is equal to 2.568. Okay, and y is equal to 5.086. Now I have two points that where the shear force is 0 and the maximum the point of the moment. Okay, so now let's draw also the moment diagram. Sorry. This is B, this is C. Okay, now I have it. So I have a moment here. Let's check. For A, do I have any moment? No, I don't have any moment for A, so I'm going to start with 0. Did you understand? I'm going to start with 0, and I'm going to increase to reach this point. For example, this point, okay? This is 1.96, okay? And then I'm going to decrease at this amount of area. And then I'm going to decrease at this amount of area, and I'm going to reach, sorry, I draw wrong. Yeah, for example, I'm going to reach at point 36.08, okay? When I decrease at this amount of area, this is 4 meter, and this is 4 meter. When I take the area of this, I'm going to reach at this point. When I take the area of this shape, I'm going to decrease to this point. Decrease to this point. So now, look at here. I have a moment, okay, as 50 at the beginning of the question. I have a 50, okay? I have a 50, so I'm going to increase, okay? At the support, the clockwise direction is going to be here as increasing, okay? So it's going to be at this 50. When I add 50, it's going to raise, sorry, 1 second. For example, this is 14, okay? For example, this is 14. Oh, sorry. Something wrong I did. Yeah, for example, this is 14. Sorry, this is 14. and 92. I'm going to add to here. For example, this is 13.92. When I add the 50 as the moment to the here, okay? So, and then I'm going to increase at this amount of area. And you know X, and you know how to calculate the area of this shape. For example, this is going to increase, okay? And this increasing is going to be 30.4, and then I'm going to decrease to 43 at this amount of area, okay? I'm going to decrease at this amount of area, and I'm going to reach, for example, the point. Sorry, I did something wrong. For example, this is 43.36. Okay, and when I decrease at this amount of area, I'm going to reach to this point. And then I'm going to increase at this amount of area. Let's check what is the force here. Yeah, now you can see the force also. I'm going to increase at this amount of area. And for example, this point, 18.76. And then I'm going to decrease at this amount of area. So it's going to reach the point 0. Because let's check why point 0. Because it ends with roller and there is no any moment, so roller and a pin, you can see this one is the roller and this one is pin. They cannot carry the moment, okay? So it has to be 0. If there is no any moment in that support, and so the moment has been closed. Now you can see the moment diagram is close to 0. So now this is B, this is A. I forgot to write the notations. And this point is this point, okay? And this maximum point is also this one. Now I guess you understand how you solve this question and draw the shear and the moment diagrams of the moment distribution questions. The question is solved. If you like these videos, if you want to see more of the videos, please subscribe and share with your friends. If I did anything wrong, please comment. I am going to try to fix it. And now that's okay. See you for the next question.